Hi everyone, in this video we're going to be looking at rearranging. So first you can see this example below. It is y is equal to a third x plus 1. In this equation we've got two variables, y and x, and currently y is the subject of the equation. So I'm actually going to look at making x the subject of the equation. So I'm going to have to move things around the equal sign, essentially rearrange so I have x is equal to as my answer. So first I'm going to look at this plus 1. I want to move that to the left hand side. In order to do that I'm going to be minusing 1 from both sides. So I'll be left with that. Now I want x is equal to, not a third of x is equal to. So you may have seen this before. A third of x can be equal to x over 3. Means the same thing. And we could read this as x divided by 3. So I have a divide by 3 on the right hand side. So the opposite would be multiplying both sides by 3. When I multiply a third by 3, they are going to cancel, so I'm just going to be left with x. And here I've got to my final answer because I've got x as now being the subject. Some of you may be thinking, well, why don't we expand that? You can expand if you like, but it's just going to be an extra step which is unnecessary at this stage. Some of you may have worked with this before as well, where you would think about dividing by a third. Let's have a look at these three then. So P is equal to a half QR at the top. I'm going to rearrange to make Q the subject. So I'm going to look at moving the R over first. And remember, in between the half and the Q and the R, there is a hidden multiply. So to get rid of the R, I'm going to divide both sides by R. So I'll have P over R is equal to a half Q. And now this is similar to what we've seen in the previous example. I've got a half Q, which is like Q divided by 2. So to get rid of that, I'm going to multiply both sides by 2. And I've successfully rearranged to make Q the subject. Let's go to this one. We have T is equal to 4/5 multiplied by S minus U. I'm going to make U the subject here. And we really need to move this 4/5. So we could divide by 4/5. And if you feel confident using that method, by all means go ahead and use that method now. Remember, if you're dividing by a fraction, it will flip to 5/4, and you'll see that on the left-hand side in combination with t. I'm actually going to use a method where I split up 4/5 and treat the numerator and denominator separately. So first, looking at the denominator, we have a 5, and essentially it's a divide by 5. So I'm going to multiply both sides by 5. Now I've done that, I've got to multiply by 4 here, so I'm going to divide by 4 on both sides. And I'm having to make U the subject. At the moment I've got a negative U, so the method I'm going to choose is I'm going to move the U over to the left hand side by adding U to both sides. And now I just need to move this 5t over 4 to the right hand side, and that will be my final step. So there are a few methods for this one, but really we all should have got to this final stage, as that is the correct answer. U is equal to S minus 5t over 4. Let's move on to this one, and I'm going to make W the subject. So first of all, I have a fraction. I'm going to have to remove the denominator. So I'm going to multiply both sides by y. And then I'm going to add 3 to both sides. Now I've got w squared on the right hand side. I just want to be left with w. So I'm going to square root both sides because that's the opposite of squaring. Now I'm going to have to add and a minus here to show that when I square root this expression, I'm going to have a positive and a negative answer. You may have seen that before, you may have not. If we look at a numerical example, say the square root of 4, most of you will be able to tell me that the square root of 4 is 2, because 2 multiplied by 2 is 4. But there's also another answer, and that answer is minus 2, because minus 2 multiplied by minus 2 is also 4. So when you square root, there isn't just a positive answer, there's a negative answer as well. So that's why I've put the add and the minus here to show that this expression will have a positive and a negative solution. So I have now got to the end point because I have made y the subject. Just to note, it doesn't matter whether your subject is on the right or the left hand side. So let's move on to a few more examples then. For this one, I'm going to make v the subject of the equation. So I'm going to have to start by moving w squared. So minus w squared from both sides. And then I have a v squared, I just want v, so I'm going to square root both sides. And again, because I'm square rooting, I'm initiating a square root, I'm going to have a plus and a minus there to show there is a positive and a negative solution. Now, we cannot cancel the square root with the squares because we have this take sign. If you don't know why that is the case, you may just want to sub some numerical values for v and y in. So try v being equal to 3 and w being equal to 1. Work it out as it is on its own and then cancel the square root and the squares and work out the subtraction, and you will not get the same answer. For the first one you'll get root 8, and for the second one you'll just get 2, and root 8 and 2 are not the same, so we cannot simplify here. This is actually going to be the final step. We've got v as the subject of the equation. Really, for this example and the last example, it looks a lot nicer if we write it this way, with v being on the left hand side. Let's move on to p is equal to q minus e squared. I'm going to make q the subject. So here, when we're rearranging, I'm going to add e squared to both sides. So I'll have p add e squared is equal to q. This one, you will have seen this with solving equations. So there's a few methods here. I want to make c the subject of this equation. And you could treat the fractions as you would with numerical fractions, so making sure you've got a common denominator. Once you've got a common denominator, adding the fractions and then simplifying where you can. Then you may have seen the other method where you want to get rid of, say, this denominator here, so you want to multiply everything by 2, but there's also another denominator here, so you'd have to multiply then everything by 3, which essentially is just multiplying by 6. So this is a method I'm going to go for. I'm going to multiply everything in this equation by 6. If you're using a different method, we should just get to the same answer at the end. So I'll have 6a is equal to 6b over 2, add 6c over 3. Now I can simplify here, so I get rid of the denominators. 6 divided by 2 is 3, so I'll have 3b, and 6 divided by 3 is 2, so I'll have 2c. Now just checking what we need, we want c to be the subject, so I might leave that there and move this 3b. So minusing 3b from both sides, and then dividing both sides by 2. We can leave it like that. If 3 was even, you may want to simplify by dividing both terms by 2, but it's not really going to make it any more simplified by doing it for this expression here. A final example to look at then, we are going to make x the subject of the equation. Note that for this example, there are two x terms, so we're going to see how that affects our working. So I'm going to carry on as usual. I've got a denominator that I'd like to get rid of. There's an expression on the denominator, but that doesn't matter. We can just multiply by an expression like we would a number. So I'm going to have y multiplied by x minus 1 is equal to 2x plus 1. Now I'm going to expand this. I'm not going to write yx, I'm going to write xy because it's in alphabetical order. Minus y is equal to 2x plus 1. Now I want to make x a subject, so I'm going to combine the two x terms and put them on the same side. So I'm going to leave this one here, and I'm going to minus 2x from both sides so it can appear on the left. So I'll have xy minus 2x minus y is equal to 1. And then this y, the negative y, can move to the other side, so I'm going to add y to both sides, and I'll be left with this line here. Now I've got two terms which have an x in common, so I'm actually going to take out an x like I would when I'm factorising, and then open the brackets and write the expression that I need to get back to both of these terms. So x multiplied by y would give me xy, and x multiplied by minus 2 would give me minus 2x. So here now I've taken out the common factor, which is x, and we're getting to the step where I just need x is equal to. Now last step, I'm going to divide by y minus 2. Remember, there's a hidden multiply here. So dividing both sides by that expression, I'm going to be left with x is equal to 1 plus y over y minus 2. Okay, I've covered quite a few examples there, so I'd like you to pause the video and have a go at these questions that feature in the notes. This will be the end of the video once you've completed those questions.